Hello guys, this is Shimanta again and welcome to my third tutorial on some very basic concepts of image processing, and today we are going to cover some implementation of the theories we have covered so far in the previous two tutorials. So I will be using Python and OpenCV as I have mentioned in the earlier tutorial, and another thing I'm going to use is Conda, which is very good for me because it comes with some basic Python libraries like NumPy and SciPy. Okay, so first I've already written all the codes, so I'm going to explain it now. So in the first code, what we're doing is importing some libraries like NumPy and definitely CV2, OpenCV2, and then we're going to read the image. I have an image here, which is named square.jpg. Yeah. So I'm going to read it here. CV2 dot, the function is same as MATLAB, image read square.jpg, and then I'm going to convert it into a grayscale image. So CV2, to convert it, we have to use the built-in function CVT color and the source frame, and then CV2 dot color BGR to gray. So it was supposed to be RGB to gray. I don't know why it's called BGR to gray. BGR and RGB is just, you know, something. So CV2 dot color BGR to gray. So what this function does is converts this frame image. It's an RGB image, so converts this image into a grayscale image. Then I have blurred the image using the Gaussian blur. It's again source, then the kernel is 5x5 here, and then the standard deviation, which has been set 0. So I have applied Gaussian blur on this gray image and saved the image into another variable named blurred. Then I have thresholded it in two different ways. The first one is O2 thresholding, and CV2.threshold is another function which comes with OpenCV, and then I use this blurred image and the source, then the threshold value. Well, as I'm doing O2 thresholding, so the threshold value has no effect here, but I have to give any value, it's mandatory, and then the maximum value. That means like if it gets if the value of the pixel is more than the O2 value, then this function is going to give that pixel the value 255. Okay, so what does 255 means? 255 means every color. It has, the pixel has got every color, so it's white actually. And finally, the method, in which method I'm going to threshold it. So CV2.threshold O2 or threshold true. And this function, the threshold function, will give you two outputs. So the first one is return value, which we don't need now, and the second one is thresholded image. Okay, so we are going to use the second one. Okay, so again, CV2.threshold, the parameters are, the first parameter is source, the second parameter is threshold value, the third parameter is maximum value, and the final one is method. So if the pixel is greater than threshold, then this function is going to assign this maximum value to that pixel. So this is threshold O2, and I have done another thresholding here, binary thresholding. So CV2.threshold, again I have thresholded the blurred image, and the thresholding value is 105. And if the value of the pixel is more than 105, then this function is going to assign 255 to that pixel, and the method is CV2.threshold binary. And again, this threshold function will give two outputs, and we are going to use the first one only. Then I blurred it again using the Gaussian blur, same Gaussian blur, threshold O2, the kernel size, and the standard deviation. I blurred both the images, and then I just showed the image, image show, the name of the window, O2 threshold, and which image I'm going to display on that window. Blurred O2 here, and also the blurred binary. Okay, and the name of the window is going to be binary thresholding. And then after imShow, I have to use this function wait key. So this parameter actually determines for how many milliseconds your image is going to be displayed. Okay, but if you put here 0, then it will wait until the user press any key. So now let's run the code. To run the code from Anaconda, first what I need to do is change the directory, because I am currently at the directory C user/user, but I have to change it where my code is. So my code is here, so I'm just copying this, and I just need to paste it here. So change directory to this, press enter. Yep, the directory has been changed. And now I have to run the code using Python. So write Python / space, then the name of the code, and it is threshold without trackbar. Okay, so threshold underscore without underscore trackbar dot py. Oops, no such file or directory. Why? threshold. Oh, sorry, thresholding without. I'm just thresholding without trackbar.py. Okay, yeah, here it is. So when I did the O2 thresholding, I got this result, and using binary thresholding, I got this. And the original image was, I haven't shown the original image here. Let's show it. So CV2, I have to write just one line, cv2.imShow. The name of the window is going to be original image, and which image I want to show in this window, that is frame. That's it. So let's save it, Control S, and let's play it again, run it again. Yep. So here's the original image. This is O2 thresholding, the result after O2 thresholding, and this is the result after using binary thresholding. Okay, so I guess binary thresholding is better in this case. All right. Okay, and the image won't go, the program won't terminate until you're pressing escape from the keyboard. So I'm just pressing escape, and it will terminate the program. Okay, so this was our first program. Now let's. The problem is here in binary thresholding, I have used a value 105, but how could I understand that the value would be a 105? I don't know. It could have been 100, it could have been 10, but how did I understand that? So to understand it, or to thresholding it manually, there is a nice thing in OpenCV. So let's do some other things here. I have imported NumPy as NP, imported CV2 again. Here's a function which we will need later. I'll come to it later. So I'm going to create a control panel here. So what will it do? So I will just I can just using this control panel, I can vary the value of the threshold. All right, so it's kind of a GUI, you know. So let's make this control panel. How to build it? CV2 dot named window. I have to create a window which will be named control, and then I have to create some track bars there. So how to create track bars? Just, it's very simple. CV2 dot create track bar, then the name of the track bar, then the name of the window, then the value, the default value, and then the maximum value, and then what will happen if the user changes the value. Okay, changes the track bar actually. So what I have done here is CV2 dot create track bar. I have named the track bar low hue. Okay, but before okay, sorry, before going to this code, let's check this one first. Now, okay, without trackbar, with trackbar HSV. Okay, I haven't opened the correct code. Without trackbar, with trackbar, yes, this one. Alright, so I have read the image frame cv2.imread square.jpg, the same image, and I have shown it the original image. Then I have changed it to from RGB to gray and saved it into gray. I have blurred it just like before, and I have showed the blurred image. Then I'm creating a trackbar. So to contain that trackbar, I've created another window which will be named control. Okay, so I have created the trackbar. The name of the trackbar is threshold. The window name will be control. The default value will be 60, and the maximum value will be 255, because we can threshold from the value is of 8-bit, so the maximum value will be 255 starting from 0. And what will happen on change? Nothing will happen. Okay, so this is a function actually, and I have defined this function here. The definition of the function is here. Just pass. Okay, nothing else. Just return it. Okay, so I have passed all the codes in a infinite while loop. First, I will get the value from the trackbar. Okay, so value will be get trackbar position. Which trackbar? The one named threshold. Yes, and where it is, it's in the window control. Okay, so get trackbar position has two parameters. The one is which trackbar, and the second one is from which window. Okay, so I will get the value here, the value from the trackbar, and then I'm thresholding the binary thresholding the image using this value now. In the previous code, I just wrote 105 here from nowhere, but now I'm going to threshold it depending on the choice of the user. So I'm going to threshold the image. Which image? What is the source? The source is this blurred one. Okay. Then what will be the thresholding value? The thresholding value will be depending on this trackbar position. And what will be the maximum value when the value of the pixel will cross this thresholding value? It will be 255. And which method I'm going to use? Binary thresholding. Okay. And as usual, as I have mentioned earlier, this threshold function returns two values. The first one is return value, which we don't need now. The second one is thresholded image. So we are going to use the second one. And then after getting this thresholding image, we have blurred it using Gaussian blur again. The kernel size is 55, and we have showed it in a window named binary threshold. The name of the window, and which image? The blurred binary, this one. And then we are going to wait for 5 milliseconds. Okay, and this wait key inside this function wait key, the parameter is for how many milliseconds you're going to wait. So we are going to wait 5 milliseconds, and then if you press any key, it will be saved into this variable ch. Okay, so I have checked whether this ch is equal 27. That is whether the user have pressed the escape key. Okay, so for the ANSI code of escape is 27, obviously. So if the user presses the 20 escape, then it is going to break from this while loop. Okay, now let's run this. So I'm going to run. I'm in the same. The code is in the same directory. So I'm going to run by using Python, and the name of the code is thresholding, thresholding with underscore trackbar dot py. Enter. Okay, here it is. So this is the original image, this is the grayscale blur image, and this is my track bar where the default value is 60. Why 60? Because I have already told the default value will be 60, and the maximum value will be 255. So let's check. The maximum value is 255. The name of this track bar is threshold, and it's in the window named control. So if the value is 255, then the whole thing is black. If I just lessen the thresholding value, then I'm getting a good image. I'm getting only the square. Okay, so yeah, this will be good, I guess. So 150. Okay, so 160 is a good value for thresholding this image. All right, so excuse me. So we can calibrate the image. We can calibrate the image using this thresholding value. All right. So really a very useful thing. And when I will press escape, the program will terminate. All right. Now let's go to the third one, where we have already said that we are not going to use the RGB color plane. Rather, we are going to use the HSV, or hue, saturation, and value, this color plane. So here we have converted the image to HSV, and we also used this control panel, the track bar thing. Okay, so as usual, we have imported numpy as np, imported cv2, and we have defined a function named nothing, which we will need later. And we have created the control panel here, and the window name will be control. And here we are going to use a range. Instead of a threshold value, we are going to use a range. Like if the hue value is from, for example, 0 to 5, then you are going to select it. Okay, so instead of using a threshold value, we are going to use a range of threshold value. So we have created a track bar, low hue value, which will be in control window. The default value will be 0. The maximum value will be 179. And if you change the track bar, it will do nothing. Okay, the nothing function has been defined here. We have also created the high hue value, high hue track bar. The high value will be, the default value will be 179, and the maximum value is obviously 179 too. We have created the low saturation value in the control window, and in the same process we have created high saturation value track bar, low value track bar, and high value track bar in the same control window. Okay, then we have read the image, a different image actually, all in one.jpg. Okay, and we have shown it in the window named original photo. And in the for loop, first we got the values, like low what is the value of the low hue value, what is the value of it, okay, or what is the value of low hue track bar. So we have collected all the values first, the low hue value, the low saturation value, low value, high hue value, high saturation value, and high value. Then using these values, using these thresholding values or range, first we have converted the RGB image to another color plane named HSV. Obviously we need to do that. So to change the color plane, we have to use CVT color. The source is frame. Let me show you. The source is frame, and then CV2 dot color BGR to HSV. All right. Then we have to create an array. Okay. So to create the array, np.array, numpy.array, we have imported numpy as np, so we can use np.array. So np.array, and then we have created an array using the low values, low, h, s, and v. And in the same process, we have created an array using the high values, high hue, high saturation, and high value. Okay, then we have threshold edit. So in the previous case, it was like if the value of the pixel is more than this threshold value, then you have to do this. But here, if the value of the pixel is in range of this value, right? So we have to use another function named in range. Then the source image is HSV. Here it is, image HSV. We have just converted the RGB image to HSV color plane and saved it into image HSV. So the source image is image HSV, and then the lower value, and then the upper value. Mind it, these things, these variables, lower value and upper value, they are actually NumPy array. Okay. All right. So what will happen here is if the value of the pixel is in between this lower value and upper value, then the value of that pixel will be set to 1. And what does 1 mean? 1 means high. Oh, sorry, 1 means white. Okay, and if the value of that pixel is not in between this lower value and upper value, the value of that pixel will be 0. Will be set to 0. So what's 0? 0 is black. Okay, so in threshold, in thresh, we are going to get a binary image again. Then we have done a simple opening, morphological opening and morphological closing operation. OpenCV has built-in functions of that, morphology X, the source image, and then which operation are you going to, do you want to operate, and then the size of the kernel. Okay, so first I have used the threshold image. I have already thresholded it, and then I want to use this threshold image to go through this operation, morphological open. The kernel size will be 5.5, so it will be saved into this variable named opening, and then opening will go through another process of morphological close, the same kernel size 5 into 5, and it will be saved into another variable named closing. And final, this is our final result, so we will show it in a window named preview. Okay, and again we will wait for 5 milliseconds, and then we will check whether the user has pressed any key or not. And if the user presses escape key, which is whose ASCII code is 27, then we are going to break. Otherwise, we are going to continue the loop. Okay, so let's play it. Python, what's the name? Fresh holding underscore width underscore trackbar underscore HSV dot y. All right. So here's the preview. Here's the original photo, and here's my control panel. Okay, so I have to set the low hue value. The low hue value is currently 0, so I'm just increasing the low hue value. Okay. The yellow square here has already crossed the limit. So for example, I want to just keep the yellow square. Okay, so I want to keep it and decrease the high hue value and fill the square, fill the circle and hexagon. Okay, it has been filled. Okay, but keep the square white. Okay, that's good. And then to improve the quality, to improve the thresholding quality, we have to change the saturation value. Okay, and decrease the high saturation value as well. Okay, we can do this. And the value of the low value, alright, it's good enough. So we can see only the square here. Okay. Now, for example, we want to keep only this circle. So again, let's So we want to keep the circle. And make everything black out of this range. Okay, 105 to 115, then the saturation value. And the value of the value. Alright, looks good. For example, now we want to keep only the hexagonal here. So again, reset it. So we want to keep the hexagonal only. So keep the hexagonal and make everything out of this range. Okay, good. Then change the value, the saturation value. And then change the value of the value. Yeah, that's it. Alright, so this is the range of hue, saturation, and value, okay, for the hexagonal. So I'll definitely give all the links in the comment section. So feel free to ask me if there is any confusion. Okay, so thank you.